This is a video presentation of 7th grade, Chapter 1, Section 10, Solving Equations by Adding or Subtracting. So, now we're finally doing the one topic in algebra that's really essential to pretty much everything we have left this year, solving equations. And you're going to see we're going to dance around quite a bit here in chapter and section number because this is really spread out over a lot of chapters and sections in the book. So we're going to start off with the basics here, just solving equations with adding or subtracting. So we've got some definitions here. The addition property of equality. That's the property that states that if you add the same number to both sides of an equation, the new equation will have the same solution. The addition property of equality is the property that states that if you add the same number to both sides of an equation, the new equation will have the same solution. And that's how we're going to solve subtraction problems. And yes, I understand it's the addition property, but the addition property is how we solve subtraction problems. And we'll see that in just a moment. I'm going to jump down to the bottom there, the subtraction property of equality. That's the property that states that if you subtract the same number from both sides of an equation, the new equation will have the same solution. The property that states that if you subtract the same number from both sides of an equation, the new equation will have the same solution. And that's the property that we use to solve addition equations. And then there's the concept of inverse operations. Inverse operations are operations that undo each other, like addition and subtraction or multiplication and division. Those are operations that undo each other, like addition and subtraction or multiplication and division. All right, so let's go ahead and take a look at the first one here where they're asking us to solve the equation b minus 7 equals 24. Okay, so there's lots of different ways you can solve equations, set up solving equations, go and look at different books, you'll see different things, but we're going to employ some pretty simple techniques here. First objective is always going to be to keep the variable on the left. Now when I say left, which is something you're going to hear me say a lot, I mean I want to keep the variable that I'm solving for to the left of the equal sign. And as you can see in the example number 1 here, b minus 7 equals 24, the variable b is already to the left side of the equal sign, so that's not an issue. Second objective, we're going to send all of our numbers over to the right. Now when I say to the right, which is again something you're going to hear me say a lot, we're going to send all of our numbers over to the right side of the equal sign. So as you can see in this question, b minus 7 equals 24. 24 is a number, and that's already over there, and that's good. 7, however, is on the left side of the equal sign, and it's a number, but it also should be on that right side with 24. So that's no good, so we're going to have to look at moving 7 there. A couple other rules that we can employ here, or will employ. Whenever I want to move something to the opposite side, I'm going to do the opposite. And that goes to that definition of inverse operations they gave us earlier. If the variable is on the right side of the equal sign, for instance, and I want to bring it over to the left side, I'm going to do that by doing the opposite. Meaning, if there's an addition sign in front of it, I'm going to subtract. If there's a subtraction sign in front of it, I'm going to add. If there's a multiplication sign in front of it, I'm going to divide. If there's a positive sign in front of it, well, I'm going to think of the opposite, which is a negative, and negative looks like subtraction, so that would mean I'm going to subtract. Lots of different ways we can analyze that in the concept of inverse operations. But again, basic rule, when I want to move something to the opposite side, I'm going to do the opposite. And then finally, last principle that's going to help us here is that we're allowed to flip the sides whenever I need to. I can literally invert everything that's on the left with everything in the right and still come up with a statement that means the same thing. So if I have x equals 3, I can flip it around and say 3 equals x. I flip the left and the right side and it still says the exact same thing. So again, variables on the left, loans of numbers on the right, ability to flip the sides whenever we need to, and opposite side do the opposite. So if we look at number 1 here where it says b minus 7 equals 24, b is a variable and it's on the left side of the equal sign. That's where it belongs. 24, that's a lonesome number. It's on the right side of the equal sign. That's where it belongs. The only guy that's trouble for us here is the number 7. 7 is a number. Numbers go to the right side of the equal sign. So as far as me moving 7 goes, I have to do the opposite to move 7. Well, look at what's in front of 7. 7's got a subtraction sign in front of it. So the opposite is going to add. So I'm going to add 7 to both sides. Now, what are you talking about when you say both sides? When I'm talking about both sides, I mean both sides of the equal sign. Everything is with respect to that equal sign. So I'm going to add 7 to the left side of the equal sign. I'm going to add 7 to the right side of the equal sign, which is exactly what they're showing you here in this first piece of work. So I add 7 on this side, and I add 7 on this side. Well, over here I've got minus 7 plus 7. Well, think about it. If I took away 7 and then I added 7, and if you're still having a hard time thinking about that, give it to a number. Take 10, subtract 7, and then add 7. Well, if I took 10 and subtracted 7, I would have 3. If I added 7, I'd be back to 10. So by doing the opposite operations, the inverse operations there, those operations or those things cancel each other out. So by subtracting 7 and adding 7, these really just go away. And then over here on this side it says 24 plus 7, that's 31. Over here I'm left with b. Well, that's good because that's what I'm supposed to figure out, what that variable equals, in this case b. Well, we just figured out that b is 31. As we can see, we check it here by doing 31 minus 7, which is equal to 24. Since both sides of the equal sign read 24, that's how we know we did this correctly. Here's t plus 14 equals 29. So same ideas here that we just used. Again, we're going to start off and we're going to say to ourselves, keep a variable on the left. So t is on the left side of the equal sign, so t can stay there. And keep numbers off to the right, so 29 being a number, that is on the right side of the equal sign, that's good as well. The one troublemaker I have here is 14. 14 is going to have to move. Alright, so let's go down here. Again, whenever I want to move anything to the opposite side of the equal sign to solve an equation, I do so by doing the opposite. So since there's a big old addition sign in front of 14 here, the opposite is going to be to subtract 14. And I, again, do that to both sides. All right, if I take 14 off the left side, I have to take 14 off the right side. And again, when I'm talking about sides, I'm talking about in respect to the equal sign. Now, you might be saying, well, why do we do that? What I want you to picture here is a balanced, double beam balanced scale. Your goal is to keep the scale perfectly balanced. So let's say I take 14 pounds off of one side of the scale. Well, the only way to keep that scale perfectly balanced is to take 14 off the other side of the scale. All right? And that's exactly what you're doing here. This is what's called balancing an equation. All right? In order to balance the equation, if you do something to one side, you do it to the other. It's kind of like working with a fraction. When we come up with equivalent fractions, think about it. If I multiply the bottom of a fraction by 6, what do I do to the top? I multiply the top by 6. It's the same thing here. All right? I take so much away from the left side of the equal sign, I then have to take so much away from the right side of the equal sign as well. So, if when I knock off that 14 on the left side, I have plus 14 minus 14. Those go away. Just leaves me t. My objective is to always get this variable by itself, because that's what I'm solving for. That's a process known as isolating the variable. And it will get more complicated as we go, but right now it's rather simple. Over here on the right side, I'm doing 29 minus 14 like it says, and that's 15. So my variable t must equal 15. 15 plus 14 equals 29. It checks. We've solved for the variable. All right, the Giants scored 13 points in a game against Dallas. They scored 7 points for a touchdown and the rest of the points for field goals. How many points did they score on field goals? So as you can see, they've translated this into an equation for us. First in words, 7 points plus the field goal points equals how many points we scored. Or in other words, 7 plus f equals 13. And then we're going to, obviously, because this section is about solving equations, solve that equation for the variable f. All right, so if we go by our rules there in terms of solving that equation, we're going to start off and say keep my variable on the left. Now my variable is on the left. Now you might be looking at that and going, well, wait a minute, that's in a different spot. You're right, it is in a different spot than the last two questions. However, it is still on the left side of the equal sign. That's all we really need. Since it's on the left side of the equal sign, we're okay. And then we're going to say numbers to the right. Well, we do have one number off to the right of the equal sign, and that's the 13. So the only troublemaker we have here is 7. 7 is going to have to move. Now, if you're looking at this and going, well, it says addition in the middle there, so I'm going to do the opposite, which is to subtract. Not exactly. The addition is stuck on the F because it's in front of the F. I don't want to go based on the opposite of what's in front of this here. I want to go based on the opposite of the 7. And this is something you're going to see in the homework for this section as well, when they try and change or manipulate the order a little bit. As far as moving the 7 there, the reason we're subtracting 7 is not because there's addition in the middle. It's all based on the 7 itself. 7 there is a positive number. The opposite of a positive is a negative, and negative looks like subtraction. So we subtract 7 from both sides for that reason. Notice what happens here is the same thing that's happened in every other problem. 7 minus 7, well, if I took 7 and added it to something and then subtracted it from something, all I'd have left is what I started with. So in essence, these guys cancel out, just leaving me my variable f. And here's 13 minus 7, which is 6, meaning they must have scored 6 points on field goals. And of course, we can check that, change my variable to f. 7 plus 6 is 13, the left side is 13, the right side is 13. Since both sides of the equation say the same thing, we know this must work. That's always the way you can check an equation. Plug in the number and make the left side say the same thing as the right side. If it does, it works. If it doesn't, it didn't work. Try it again. So let's go ahead and try a couple last questions here. Solve the equation y minus 3 equals 21. So again, we're going to say to ourselves, keep that variable on the left, which we do. We have y on the left. And keep our numbers off to the right. Well, we do have 21 to the right. So the one troublemaker here is the 3. 3 is going to have to move because numbers go to the right side of the equal sign when we solve an equation. So we're going to move the 3. How am I going to move the 3? I'm going to move the 3 by doing the opposite. Since the 3 has a subtraction in front of it, the opposite is going to be to add 3 to both sides. So over here, this minus 3 plus 3 cancels each other out, and here's 21 plus 3, which is 24. So my solution is y equals 24. Does this make sense? Well, 24 minus 3 is 21. This side would equal 21. This side would equal 21. The equations are in balance, so my answer makes sense. Number 2, solve the equation x plus 11 equals 36. So again, variable on the left, numbers off to the right. So, and again, when I'm saying left and right, for the too many times today now you've heard me say it, when I'm talking left and right, I'm talking in relation to the equal sign. Left side of the equal sign, right side of the equal sign. All right, numbers off to the right of the equal sign here, so the guy that's in trouble here is the 11. I'm going to have to move 11, and I'm going to do that by doing the opposite, which in this case implies that I'm going to subtract 11 from both sides. Notice this has got a plus in front of it. The opposite, as we know, is to subtract. So I've got 36 minus 11, which is 25. X equals 25. And again, we can check that. 25 plus 11 here is 36. 36 on the other side, since both sides would equal 36, we know we did this correctly.